DeepSeek did it again, shaking the world of artificial intelligence. A picture is worth 1,000 words. It literally took that seriously. It's a two-step VLM, vision language model, that compresses text into visual token and then decodes them back with high fidelity. But what it's really aimed at is solving long context for LLMs. So why does this matter? LLMs are notorious for forgetting things that go outside of the context window. In fact, Sam Altman said that is the #1 pain point for having LLM agents today, is that they can only remember what's in their context. But today, that's about to change. With DeepSeek-OCR, we don't care about the OCR. Yes, it's a fantastic open source OCR model, but that's not the point. The point is what they did. What they did is they came up with a way to take a picture is worth 1,000 words and actually implement that. It's a proof of concept for compacting language tokens into images. Let me explain more. An LLM, the biggest bottleneck is the context window, which is essentially how many words can an LLM remember. For instance, you give ChatGPT a piece of information, like let's say your name, and then you speak to the same conversation for days, you're going to find that it might not remember what's at the top of the conversation. Now, OpenAI does do some interesting stuff with memorizing information across chats, but that's not what we're talking about today. What we're talking about today is far, far different. I mean, for instance, for every token that you have in a context window, the amount of compute needed for every LLM is increased quadratically. So imagine if we can compress the tokens that are needed to remember key points of interest into something a lot more manageable for long-term memory usage. So what if we could get 10 times the amount of context into a context window by not changing the architecture of the model at all? And that's essentially what DeepSeek is suggesting here. So how does it work? Essentially, we have an image, right? This image contains text. And the text can be quite small, but we don't want it to be too small because otherwise we get introduced to noise and other issues. Then what happens is DeepSeek-OCR will chop that into 16 by 16 patches. And then it's passed to an 80 million parameter model called SAM, which is a tokenizer. And then it compresses it again. Then it takes the tokens that it has compressed and puts it into CLIP, which is a 300 million parameter model. And this basically embeds all the tokens so that we have embedding. Now, DeepSeek 3 billion will go ahead and decode that into Markdown into human readable text. So essentially, we have a fully working system where we can increase any context window by 10x. The only downside that I can see here is the latency. You're going to have a slightly more latency because you got to convert text to images and images back to text. But for complex topics or for long context windows, you know, entire code bases, novels, anything of that sort, this is going to be extremely useful for people. But even as they say right here, they are only presenting it as a proof of concept. For efficient vision text compression, our work makes 3 primary contributions. First, we provide comprehensive qualitative analysis for vision text token compression ratios. Our method achieves 96% OCR decoding precision at 9 to 10x times text. So like I said, it can hold 9 to 10 times more text through this compression method than a standard context window. But as you see here, as the compression increases, they go from 96% to 90% to 60% at 20x compression. So it can hold more. However, you are then losing accuracy at that point. Well, what are people saying about it? Andre Kaparthi says, I quite like the new DeepSeek OCR paper. It's a good OCR model. So even as it is, it's an amazing OCR model without the whole proof of concept for extending LLM context windows. And he even says it poses the question whether text tokens are just wasteful and just terrible as input. And maybe it makes more sense that all inputs to LLMs should just be images. And even further, to be clear, it's not just text. It's a general OCR model. It can recognize people, objects, humans, even handwritten text. So how do they do it? Document data is the top priority for DeepSeek-OCR. We collect 30 million pages of diverse PDF data covering about 100 languages from the internet, with Chinese and English accounting for approximately 25 million and other languages accounting for 5 million. For this data, we created 2 types of ground truths, coarse annotations and fine annotations. So here's an example. On the left here, they provide a ground truth image, and on the right here, they perform an annotation with layouts. So this really seems like a critical breakthrough when compressing text into images. I don't think that I would have ever thought of this if I was the DeepSeek team, so hats off to them. Anyways, thanks for watching. Hope you enjoyed.